Hi there. This year I have, for the first time, grown a couple of wild potato species, and the one I want to talk about today is this one, which is Solanum jamesii, also known as Four Corners potato or Colorado wild potato, Texas wild potato. It is native to and indigenous to the United States. There's actually a large number of Solanum potato species that are native to North America, but most of them are from Mexico. But there are 3 species of wild potato that are indigenous to the US, and this one is probably the most well known. It is a really fascinating species, and it is known that Native Americans in the desert Southwest, especially the cultures that are sometimes called the Anasazi, at least semi-cultivated this. They're the most abundant, genetically diverse collections of Solanum jamesii are usually located near Anasazi and other Native American archaeological sites, and the current discovered center of diversity for Solanum jamesii is actually in Mesa Verde National Park in southern Colorado. So the Native American peoples use this species as food, and there is direct archaeological evidence based on starch grain remains on very ancient stones and stone tools and pottery from almost 8,000 years ago. So there's a very long history of Native American symbiosis with this species. And so I've grown it just this year, and it's been a really interesting experience. And so I'm gonna just start digging some more of these tubers, and while I'm doing that, we can just sort of talk about the various things to know about Solanum jamesii. Things to know about Solanum jamesii. It is kind of a really extreme plant. It's capable of doing a lot of really extreme things. It is considered to be one of the most frost tolerant, cold tolerant, freeze tolerant tubers of any potato species. So the tubers are capable of surviving being frozen for at least short periods down to, I think it's like -10 below zero, and they can survive indefinitely frozen a couple of degrees below zero. So they have incredible frost tolerance, and they have insane levels of tuber dormancy, to the point where they have, in the laboratory, they have stored Solanum jamesii tubers in dry conditions in a refrigerator for 10 years, and the tubers still sprouted. So it has an incredible ability to maintain viability and dormancy until conditions improve, basically. So you can see the tubers average rather quite small, but and then the other thing, and one thing that I did really wrong, and I wouldn't recommend you do this, is I transplanted these directly into the ground, and not really thinking about the implications of the fact that it is a wild potato, right? And wild potatoes are very different than cultivated potatoes. And so when you think about a cultivated potato, we've selected cultivated potatoes to like put all of their tubers right near the seed piece where we plant them. But if you're a wild potato, that's a really stupid strategy, right? Because you want your tubers to survive in the future You don't want them all in one place where it's where a disease could damage them, or where an animal could come and eat all the tubers at once, or where one mishap could destroy all of your ability to vegetatively propagate yourself. So a wild potato does what these do, and it shoots out stolons very, very, very far from the parent plant. And so I am in no way going to be able to collect every single one of the tubers that these plants produced, because I didn't make allowances for that. And so what should be done with a wild potato like this, if you want to be able to collect all the tubers, you need to grow them in a pot. And there was a really fascinating article that I read recently about a project in, I think, the Navajo reservation, and they were growing Solanum jamesii, and they were going to use them in a dinner. And there was a picture, and they grew them in pots, and there was a picture, which I will try and get a copy of the picture and put it up right now, but the pot was so full of these stolons, and basically it looked like a pot full of spaghetti interspersed with these little tiny tubers. It was like spaghetti and meatballs. It was just crazy. It was just like you couldn't even see the soil that they'd planted the tubers in. There were so many stolons wrapped around and around and around in those pots. And like, I had these jamesii planted right in this area, and the tubers were, I was locating them all over the place, and I'm sure they're over in the weeds also. So that's going to be a challenge going forward, maybe. So I think it has a small potential to become invasive here, and I shouldn't have planted them this way. I should have put them in pots, but I'm not too worried about it, because the one thing, the plants are very small. They're only about maybe 8 inches at their biggest, and so all of the pasture grasses that were growing up, they were kind of getting out-competed by the weeds in the pasture grasses, because they're a desert-adapted species. So I was kind of babying them along a little bit, although they did do really well. I've collected a lot of berries off of them. There's actually a few little berries here, but I have some good pictures that I'll put up right now of what the berries look like. Yeah, so they're wild, and they're going to act wild, but I'm not too worried about them becoming like naturalized here, just because even though I'm sure they can survive our winter temperatures in the soil based on the research, I just don't think the size plants that they produce, that they can actually compete with the native vegetation here, because they're actually normally growing in like places like Mesa, Verde, Chaco Canyon. They grow in the desert, although I was really, really happy with how well they did here. The seedlings, like most potato seedlings, were really tiny, but they did some stuff that was really interesting and unusual compared to Solanum, regular potato seedlings. They, right after the seedlings got maybe about 1 inch tall, the potatoes shoot out side shoots from the little meristems in the leaf axils, and in a regular potato, those would be new shoots, new stems going upwards and producing new leaves. But on the jamesii, they produced these sort of purple stems that came out, and then they dove down into the soil and became stolons. And I'll put a picture up right now, because you can see those stems coming off the baby seedlings and going down into the pots. And so their first instinct was to start tuberizing and sending stolons down. It was fascinating. And I should have realized right then how aggressive stolonizers they were, but it didn't really occur to me, and so I still just planted them out like this. And you can see I'm actually getting a lot of tubers, but I'm sure there are almost just as many as I'm collecting I'm missing. You know, there's just no way that I'm finding everything that's here. Now, what else to know about jamesii? Jamesii, I talked about the extreme, you know, freeze tolerance of the tuber, the incredible dormancy of the tubers. So one of the things I want to do is I want to have an experiment. I'm going to take some of these, I want to do some dormancy experiments for myself and take some of these tubers and, you know, put them in dry peat moss and store them in the fridge and see, you know, in 2 years' time if they'll still germinate or sprout and form new plants, which I'm pretty sure they will. And I also want to try like directly burying the tubers like in a glass bottle or something, you know, burying them upside down. I read about this experiment about weed seed viability, and I can't remember right off the top of my head what university, but some scientist decades and decades ago collected a bunch of different weed seeds and put them in bottles, and then he buried them all around the campus of the university he was at. He and then following researchers would dig them up periodically and germinate those weed seeds, and, you know, they were able to like sort of determine like the upper limits of the viability of germination of various weed species by, you know, continually digging up these sort of buried treasures of these weed seed bottles. And so I kind of want to do something like that, where I bury some tubers, some jamesii tubers, in a sort of way in which they'll stay dry, and, you know, and then they're kind of down deep where they're in like sort of stable temperature conditions, and then just see how long they remain viable there. It seems to be dryness is a necessary condition for their dormancy, you know. So like basically they're induced to begin growing when, you know, the drought stops, and then they'll start, the tubers will start growing and then form new plants or something. So I want to kind of play around with keeping the tubers like cool and dry, and then see how long they'll remain viable. And I'm kind of still discovering like how deep down the tubers go. You can see this is the quantity that I've harvested so far while we've been talking. What else to know about jamesii? So edibility. Native Americans did eat it. There is considerable evidence that they ate it with sort of a edible clay combined with it, which is a thing that South American Indians do as well, and that acts to absorb any alkaloids that are present in the tubers, so that they are just basically passed through your digestive system without you absorbing the alkaloids. And the level of glycoalkaloids in jamesii tubers is sort of undetermined, but the ones that have been tested, they've been in the range of 150 micrograms per kilogram. I believe that's the right level. And the type of glycoalkaloid is tomatine. And tomatine is actually the same glycoalkaloid that's in tomatoes. So if you've ever eaten like green tomatoes, you've actually eaten kind of a similar level of glycoalkaloids as what are present in the accessions of jamesii that have been tested. So that doesn't mean, you know, currently more accessions of jamesii are being tested for the levels of glycoalkaloids and yeah, just their general glycoalkaloid level. But it's not really clear how safe these are to eat. It is known that Native Americans ate them, and that it is possible to eat them. I've already eaten some, and I haven't gotten sick. And it's also actually not very clear from the literature how toxic tomatine is compared to the glycoalkaloids that are in tuberosum, like domesticated potatoes, because domesticated potatoes have solanine and chacoine as their primary glycoalkaloids. And one thing that they've determined from research is that humans have difficulty detecting varying levels of tomatine, whereas humans don't have much difficulty detecting like toxic levels of solanine. So if you have too much solanine in a food that you're eating, it's bitter and repellent, so you stop eating it. But tomatine, potentially, the human taste receptors are not as capable of detecting high levels of tomatine. But it's also kind of undetermined like how toxic tomatine is. You know, it's kind of anecdotally clear that tomatine is way less toxic than solanine is, but there's a lot of stuff that hasn't been researched too much. I mean, people eat green tomatoes all the time. So yeah, I'm gonna keep playing with Solanum jamesii. I'm gonna keep digging. I've got a pretty large planting of these, and I'm just really interested in this species and its potential for becoming like sort of a new domesticated, or at least part of a new domesticated potato species. There's a number of other similar potato species from Mexico and from South America. One of them is Solanum cardiophyllum, which is actually a Mexican potato that is fully interfertile with Solanum jamesii, and those have larger tubers. They have very low, at least some accessions of them have very low glycoalkaloids, and they have, you know, so the potential is there for the two species to be bred together and to get some of the really fascinating qualities of jamesii and cardiophyllum. And then there's another species from South America called Solanum jamesii, which has really large tubers and some other interesting, you know, frost resistance traits and stuff, and those are interfertile with jamesii. So I want to experiment, you know, in the coming years with, you know, playing around with crossing jamesii with some of those other species and seeing what those hybrids look like and what they taste like and what size tubers they are and how palatable they are. And yeah, that should be a really interesting project. I don't think, you know, it's not like, oh, I'm going to domesticate a potato species all by myself, but it's kind of a fascinating idea, I think. Yeah, so it's just like, and obviously for all the, oh, one more thing about jamesii. I actually had the privilege of speaking with Dr. John Bamberg, who's kind of the lead researcher on Solanum jamesii, and one of the things he told me was, of all of the Solanum species that they've tested, the blight resistance of Solanum jamesii is the highest that they've been able to determine of any potato species. And essentially, Solanum jamesii is completely immune to late blight, which makes sense. Most Mexican species are highly, highly tolerant or resistant to late blight because late blight is actually native to Mexico. And so all of the Mexican potato species that have co-evolved with late blight, and all of the North American, you know, potato species have co-evolved with late blight and are essentially immune to it. And jamesii is one of those species that's immune. Freeze tolerant, super dormant, blight resistant, and it is native to North America. It's just a fascinating species, and it is something I want to keep growing. Yeah, and it grows here. I was really happy with how well it's done. Now, obviously, this is not a huge yield. You know, if this was a regular tuberosum potato, I would be like, why am I even bothering with this? But I'm just fascinated by it. It's native to Colorado. I grew up in Colorado. I was born in Colorado. I just like growing this species, and I'd like to see if I can make it easier to grow for other people. And the other idea that you could possibly do would be to, if you cross Commersoni and jamesii, and then you double the genome of Commersoni and make a tetraploid Commersoni. Sounds like we're about to get a bunch of rain. Is that just wind? Nope, that's rain. Okay, we're calling it because it's gonna rain. I hope this was interesting. I hope this was educational. Thank you very much for listening to me jabber on about Solanum jamesii. And thank you very much for watching.